Okay, any questions so far? Leap year is always fun. It's got to be, the year has got to be evenly divisible by 4 and not divisible by 100 or 400. And so there are your rules. So in this particular case, we've got an if statement. We're saying if it's divisible by 4 and it's divisible by not divisible by 100, or it's divisible by 400, then it's a leap year. That's kind of the rule for a leap year. So, we could easily enter something here in this example and just say, put this right here. And we'll just change this to year. We could prompt for it. I'll just say here, leap year. Ooh, I hate when that happens. It's an A. So if I make this, 2000, that would be, I'm pretty sure. No, actually, would it be a leap year? Yes, it would be a leap year. We run that, it's a leap year. If I make that 2001, it's not a leap year. Right? If I change that to 12, it's a leap year. And so forth. And you can play around with it, but that's how you get it. Lottery is another one. This probably uses the random number generator. And let's see if we can find a. Sure, if you could email it to me, that'd be great. Okay, so let's create a new Java class. Call it lottery. So they're getting the input and doing some information there. So lottery is using what's called a random number generator, which is part of the math class, to randomly just pick a number. And the way the random number generator is it generally works off of your clock ticks. Your clock ticks are accurate to the millisecond, so it's usually looking at what the current millisecond is and using that to pseudo-randomly generate a number. Not a true random number, but it's as close as a computer can get. And then it's just going to compare those numbers to what you entered. And then they'll tell you, if you guessed the lottery, you won. If, I guess, one of the digits is correct, you won something. And then if, it looks like there's some conditions on what combination of numbers, and then you win 1,000 and so far. Go ahead and run this, and it's going to say, okay, enter 2 digits. I'm going to enter 20. Oops. 25. Lottery number is 5. Well, I got $1,000 because I entered a 5. So you can see how it works. It's went to 25 again. Sorry, no match. So that's the important thing to look at there is the random number generator, because we'll use that. Random number generator is used a lot when writing programs, game programs. You really wouldn't be able to write game programs without the random number generator, because games have to do things randomly. Compute taxes for a switch statement. Okay, now the switch statement is a sort of a specialized if statement. It looks at a single value and it'll allow you to look for an exact match on a single value. And then based on that, you've got multiple possibilities. Each case is kind of like an if, else if, else if, else if, and the default is like a final else. But it's somewhat limited, but it's actually useful when you're processing single values. So it has some value. All right, and the flow chart looks a little like that on a decision. All right, so it shows you what it's doing. The break. Now, the reason you need the break is that the way the switch statement it works is a little different than an if. Is that as soon as something becomes true, it falls through and it has everything else in the select, in the switch case, actually. So you have to break it in order for it to not continue. So it doesn't stop as soon as it finds a match. It keeps going. Sometimes that's what you want it to do, but not always. And switch statement only works on simple data types like integers or A's or something like that. So in this case, you could say, what letter did you enter? If CH is an A, then it'll print. Actually, it's going to print ABC. Give you a look at how this output works. With the break, it'll do something different. So let's just. Let's see. Char. Okay, so if we run this, actually, make that a lowercase a. We're actually going to get ABC, not just A. Okay, no. Oh, I see. So we get A 3 times. Okay. If I add the breaks in, we'll only get it once. So without the break, it does as soon as it finds a match, it does that and just keeps going. Like everything else is part of it. So in this case, we only get one. So that's the difference with break and not having a break. Well, because it's printing CH every time, that's why. Printing CH every time, that's why. And CH is A. Then it breaks. The zodiac. Enter a year. Alright, so let's try the zodiac. Which just asks the user to enter a year, and then it tells them, what their Chinese New Year is, or their. So enter a year. We could enter 1980, I guess. Year of the monkey. So if you're born in 1980, you're year of the monkey. Yeah, the conditional operator is what I showed you before. It's a shortcut referred to as a ternary operator. I wouldn't bother using it for now. It's a shortcut to a regular if statement, but it gets a little confusing. So at this point, I would just say, don't worry about it. Eventually, as you get better, you'll start taking these shortcuts on your own, but don't worry about them right now. So that's just to say, are they even or not? And this is another example of using the shortcut operator, which I'm just not going to bother with. Printf is useful command. It actually comes from the original C language. It wasn't originally included in Java, but due to popular demand, it was added. It allows you to create sort of a string template and substitute values in after the fact. It's actually a more efficient way of putting variables into strings other than concatenation. And it works by using placeholders. %D, these are all the percent some letter is a placeholder for a certain data type. So %B is true or false, %C is a character, %D is a decimal or an integer, F is a floating point which includes a double, E would be exponential, and then S would be string. These are your operator precedents, the order in which operators work. So the ones on top have higher precedence to others, and just like math, you can play with the precedence using parentheses. Again, using parentheses, you can actually change that order of operation if necessary. So again, you have a certain associativity with these. Plus and minus will be read left to right. If you had some combination of multiplication and division in there, then it would not necessarily read that way. These are the same exact rules that you have in math with operators in math. And again, this just kind of goes through and shows you how it figures the whole thing out. And this is just math. You could work through an algebra equation. It just works through it the same way you work through it in math. Confirmation. I think we looked at some of these last week. The J option pane. We already did that one. So as far as the operator goes with the output, so let's see if I pick one of these. Right now, for example, this is doing a whole bunch of stuff and concatenating it. So I can change this to using the formats. Do it all on one line. Let's see, it's going to do %D for decimal or integer is %, what is that? No, what is it? It's double. So this needs to be %F for double, and then this one is going to be %F for double as well, and then I kind of get rid of these things. I do have to put one here. So it's a lot cleaner to use this format instruction, and the 2%Fs will be substituted in for the radius and the area. So we can see how that works.